Now that you have a better idea of how we can use opposite, adjacent, and hypotenuse to determine the length of sides or angles in a triangle, let's start taking a look at trig ratios. There are three trig ratios. There's a sine ratio, there's a cosine ratio, and there's a tangent ratio. In this triangle, we're given angle theta. And theta is used just like x and y. It's a variable. And because this is the angle that we're going to be focusing on, and it is a right angled triangle, we can label our triangle with the hypotenuse opposite the 90-degree angle. The opposite side to the angle that we have is over here, and this side here enclosing the angle theta is along the bottom. Now that we've labeled our diagram, we can state our trig ratios. One of the ways to remember trig ratios is by using the acronym SOHCAHTOA, and it helps us remember that sine ratio is going to be the length of the opposite side over the hypotenuse. Cosine is going to be adjacent over hypotenuse. And finally, the tangent is going to be opposite over adjacent. So let's use our trig ratios to state the relationship or the ratios of sine theta, cosine theta, and tangent theta. The first step is always to label your diagram. So here's the angle that is given down at the bottom. That means that the opposite side is over here, adjacent is here, and the hypotenuse is always opposite the 90-degree angle. And we know that sine theta is equal to opposite over hypotenuse. So we can state that the ratio sine theta is going to be equal to opposite, which is 9, over hypotenuse, which is 15. So for this triangle, sine theta is going to equal 0.6. Cosine of theta, if we take a look at our SOHCAHTOA acronym, is going to equal adjacent over hypotenuse. And the adjacent side is 12, and the hypotenuse is 15. For this triangle, cosine theta equals 0.8. Finally, tangent of theta, if we take a look at our acronym again, we see that tan of theta is equal to opposite over adjacent. And for this triangle, the opposite side is 9, and the adjacent side is 12, and this ratio ends up being 0.75. So tangent of theta is 0.75. Let's take a look at the second triangle. Again, let's start off by labeling it. Here's the angle that we're given up here. So now, in this case, the opposite side is down here, and the hypotenuse is always opposite 90-degree angle, which is over here, and that makes this the adjacent. So our sine ratio is going to be, again, taking a look at our acronym, opposite over hypotenuse, and in this case the opposite side is 8.5 and the hypotenuse is 11.4. The cosine of theta is going to equal adjacent over hypotenuse, and the adjacent side is 7.6 over 11.4. And finally, the tangent of theta is going to equal opposite over adjacent, with the opposite side being 8.5 and the adjacent side being 7.6. Let's get our calculators out and figure out what these trig ratios are. So for the second triangle, sine of theta is going to equal 0.7456 rounded to 4 decimal places. Cosine of theta is going to equal 0.6667 rounded to 4 decimal places. And the tangent of theta is going to equal 1.1184 rounded to 4 decimal places.